Okay, so in today's lesson, we're going to be finding percents using different strategies to help us. Just as a review, a percent can be written as a fraction with a denominator of 100. So if we can get the denominator to 100, whatever the numerator is, that is the percent. So we can use a tape diagram to model percents. That's one way we could help. That's one strategy that could help us find percent. So for example, in the first problem, the tape diagram represents the charge of a cell phone's battery. What percent of the battery's charge does each unit of the tape diagram represent? So if we're starting with 100% and we're splitting that into 5 equal pieces, each unit represents 20%. And again, we're getting that because we're doing 100% of the total thing and we're splitting it into 5 equal pieces. So 100% divided by 5 is going to be each one of those units is 20%. So what fraction represents the battery's remaining charge? Well, we have 2 of them. So if each one of them is 20%, 20% times 2 would be 40%. So we have 40% remaining on the battery. All right, and then what fraction represents the battery's charge? Oh, I'm sorry, and it says what fraction. So this would actually be C. So let's do C. What percent of the battery's charge remains? 20% times 2 would be 40% that remains. And then what percent of the battery's charge has been used? So 100%. And we used 40%. I'm sorry, I'm all over the place. 100% is the total amount. 40% is what's left. So how much did we use? 60% has been used. All right, and then 20% times 2 is 40%. So that's the remaining charge. All right, and then I'm going to erase right here because this one is asking us for a fraction. It's asking us what fraction remains, right? So how can we write 40% as a fraction? 40 over 100, and we could divide them both by 10. And so we could write 4/10. And this can also be reduced, so we could divide both of those by 2. And so 2/5 is what's remaining of the charge. All right, and then it says what fraction represents the battery's charge that has been used? So again, we have 1, 2, 3 of them, and each one is 20%. So that would be 60%, and we could write 60% as 60 over 100. Again, we could divide these both by 10, and so we would end up with 6/10. And same thing, we could reduce this again. We could divide by 2, and we'd end up with 3/5. And we know that this is true because 2/5 plus 3/5 will give us 1 whole. All right, and we have to have our sum add up to 1 whole because it's 100%. If we fully charge the battery, we'd be at 100%. So that's one way you can check your answer for those types of problems. All right, the following students estimate the number of hours their cell phone battery will last when it has a whole charge. Ryan's phone battery lasts 10 hours. How many hours will Ryan's phone last when the battery charge is 40%? Draw a tape diagram to determine your answer. Okay, so I'm going to draw a tape diagram. And I know that the whole thing is 100%. And I'm looking for 40%. So I could split this into 5 equal sections, just like the previous problem. So we'd have 1, 2, 3, 4. Draw 4 lines, and we end up with 5 equal sections. 20%, 40%, 60%, 80%, and then 100%. And so what are we doing? We know that the whole thing lasts 10 hours. So if it's fully charged, it's going to be 10. And again, we're splitting that into 5 equal pieces. So in this case, we're counting by 2. So 2, 4, 6, 8. And this is the hours. and this is the percent. And so 40% would be 2 and 2, which is 4. So Ryan's battery will last 4 hours. All right. Next, it says Kayla's phone battery lasts 15 hours. How many hours will Kayla's phone last when the battery's remaining charge is 40%? So again, we can count by fives. So we end up with the 40%. And the whole thing is 15 hours, and this would be 100%. And so we're splitting this into 5 equal pieces. So 1, 2, 3, 4. I need to draw 4 lines. It creates 5 equal pieces. This is 20. This is 40, 60, 80, and then 100%. So all of those are my percents. And then each one of these, 15 divided by 5, each one of these represents 3 hours. And how am I getting that? I'm doing 15 hours divided by, I'm writing it wrong. 15 hours divided by 5, because we're splitting it into 5 equal pieces. So each section is 3 hours. And so 40% would be from here to here. 3 plus 3 would be 6 hours. All right. And then C says Riley's phone lasts 8 hours. How many hours will Riley's phone last when the battery's charge is 40%? Draw a tape diagram to determine your answer. Okay, so 40%. Again, I could split this into 5 equal pieces so that I end up with a 40 in my answers. I need to draw 4 lines so that I have 5 equal pieces. 20, 40, 60, 80, 100. And so I know that I need this one right here because it's 40%. So my total is 8. So now the problem, it makes it a little bit harder because 8 is not a multiple of 5. So you're going to have an integer as an answer, not a whole number. So 8 divided by 5 is going to be 1. It can go 1 time into 8. And then if you could write it as a fraction, 3/5. And then you could multiply this part by 2 so that you get it as tenths. So this is 1 6/10. And so we can write 1 6/10 as 1.6. So 1 6/10. So each one of these is 1 6/10. All right, and we're at 40%, so we need 2 of the sections. So 1 plus 1 6/10 and 1 6/10 will give us 3 2/10. So it's 3 2/10 hours is our answer. All right, and then part D, Lacey's phone battery lasts 6 hours. How many hours will her phone last when the remaining charge is 40%? Draw a tape diagram. So again, I'm going to draw a tape diagram. I'm going to split it into 5 equal pieces so I can get that 40%. So 100% would be here. I'm splitting into 5 equal pieces, so I need to draw 4 lines. 1, 2, 3, 4. And so you have 20%, 40%, 60%, 80%, and then 100%. And I'm doing 6 total hours divided by 5 because there are 5 equal sections. So 6 divided by 5 is going to be 1 whole and 1/5. Again, it's easier to write a fraction if we have it out of tenths. So I'm going to multiply by 2. And so I end up with 1 2/10, which is the integer 1.2. So each one of these pieces is 1.2 hours. And I'm talking about 40%. So I need 2 of them right here. This would be my 40%. So 1.2 and 1.2 gives me 2 4/10. So my answer is 2 4/10 hours. All right, and again, this is just another strategy that we can use to solve percent problems. I am going to skip number 5 just because this unit has a lot of lessons, and all it's doing would be just completing the tables from these answers. So you'd be just putting them in the column that they go with. And I don't think we really need to go over that at this time. There are more important problems we could work. So I'm skipping the table for now, and I'm moving on to these problems. So it's saying that we can use any method to solve these problems. 13 out of 20. So we're writing a fraction. 13 out of 20 is what percent? So we're looking for the percent. Remember that if we can write this with a denominator of 100, then we can just say whatever the numerator is the percent. So how do I get from 20 to 100? Times 5. Do the same thing to this, times 5. And 13 times 5 is going to be 65. So 13 over 20 is equivalent to 65 over 100. And because we have a denominator of 100, we can write this as 65%. So sometimes it's easier to just write it as a fraction and convert your fraction to an equivalent fraction with a denominator of 100. Or number 7, 18 out of 36. And this is when it really helps to know your math facts and your factors. I know that 18 and 36 are both multiples of 9, so I can divide this by 9. 18 divided by 9 is 2. 36 divided by 9 is 4. And what do I know about 2/4? I know that this is half. And so what is a half of 100%? It's just 50%. How can we prove that with math? 2/4 times 25. Think about quarters. You get 50 over 100, which is 50%. All right. What percent is 24 out of 80? So 24 out of 80. So this is one where it seems kind of hard because it's like what times 80 gives me 100. But I could turn this into a denominator of 10 by dividing by 8. Both 24 and 80 are multiples of 8, so I can divide them both by 8. I end up with 3/10 times 10 to get it out of 100. I end up with 30 hundredths, which is just 30%. All right, so again, knowing your factors and your multiples can really help with these, because if we can get it to a multiple of 100, then it's going to make our problem really easy. 17 out of 85. So if we get something like this, I know that 17 is prime. So there's nothing that I can multiply or divide by to get 100 easily with this type of problem. So when you get to something like this and you don't have a factor or a multiple that can help you get it to 100, you just divide. So we're going to put 17 inside and we're going to divide by 85. Again, before we even start, 17 out of 85 is less than one whole. You would need 85 pieces. You would need this, 85 out of 85 to equal one whole. You only have 17. So that's telling me that my answer is going to be relatively small. And I should get a decimal answer. I should not get something over 1. It should be less than 1. 85 can't go into 17. So put your decimal, add your 0, 170. So I know that 85 can at least go one time, possibly 2, because 2 times 8 is 16. So I'm looking at that first 17 and 16. So I'm going to try 2. It might be too big. I might have to restart, but I'm going to try 2. 2 times 5 is 0, carry my 1. 2 times 8 is 16 plus 1, 170. Subtract and you get 0, so you are done. So your answer is 2/10. But remember, we want to change this to a denominator of 100. So we're going to do times 10 times 10. So we end up with 20 hundredths, which is 20%. All right. You can also use a double number line to practice percents. Again, there are none on the test where the percent is over 100%, but I just want to work a few problems just to kind of make sure if you get one of these in the future, you kind of have an idea of what to do. I'm not going to do the double number line. However, I'm just going to skip number 10 and go straight to 11. All right, so number 11, it says that we have 18 is what percent of 15? So we're writing, again, we're looking for the percent. So it's 18 over 15. To find the percent of that, I know that both of these are divisible by 3. And so I end up with 6/5. All right, and so at this point, I know that I can change this to a denominator of 100 by multiplying by 20. And so I end up with 120 over 100. So I can write that as 120%. And it should be over 100% because my numerator is greater than my denominator. So 100% would be 15 of 15. And this is more than that. This is 18 over 15. So you should have an answer greater than 100. All right, for my next one, 450 divided by 150. The first thing I would do when I have this is I would divide them both by 10. And you end up with 45 over 15. And it's the same concept. You could divide them both by 3 and get it to 5 and then multiply by 20. So that's one way you could do it. But I know that 45 divided by 15 is 3 wholes. And if each whole is 100%, you have 3 of them. So you have 3 times 100%, which is 300%. 21 out of 20, so 21 out of 20. Again, I can multiply this by 5 to get it out of 100. 21 times 5 is going to be 105 over 100, so this is just going to be 105%. All right, and then the last one, 675 out of 500. Honestly, on this one, I would divide them both by 5 because this ends in 5 and this ends in 0. They're both multiples of 5, so I can divide them both by 5. And I end up with 100 and 675 divided by 5. 5 goes into 6 one time. Subtract, bring down. 5 goes into 17 3 times. 3 times 5 is 15. Subtract, bring down. 5 goes into 25 5 times. And you are done. So your answer is 135 out of 100, which is 135%. All right, and that's all for today for this lesson. Again, if you could write it where the denominator is 100, then all you have to do is write that number, the numerator, as the percent, because a percent can be written as a fraction with a denominator of 100.